Ready. Hope you're all doing well as the semester is going. Today we are going to continue the abstractive summarization portion of our summarization. And then this will bring us to how do we evaluate for text generation. We are going to start in the context of summarization. So we are generating summary, but what we are going to talk about in terms of the text generation evaluation is something that concerns all sorts of text generation tasks. And given that these technologies today, like ChatGPT, are designed to generate all sorts of text, you can think about when we talk about text generation evaluation as evaluation of anything that you can possibly generate with ChatGPT. Before we move forward, are there any questions about the logistics of the course, assignment, some of the previous topics we had talked about, anything at all? All right. Okay, feel free to stop me. I will try to monitor the chat. But if you are in a position to just unmute yourself and say your question, that's slightly easier for me than context switching between slides and the chat. Okay, so remember the last time we talked about summarization and I introduced this example from NPR article about the Boeing situation, and then we were looking into how we can summarize that article. And I talked about three different ways you can present a summary, one of which is this extractive summary, where you are selecting full sentences from the document and present that selection of sentences as your summary. And first, I have given you some pre-neural approaches of how you can go about that. We haven't seen how we actually find the parameters of those pre-neural approaches. We have just seen the formulation of the problem, and then we have moved into the BERT for extractive summarization, where we did something very simple. We had just these special CLS tokens and first of every possible sentence.
Great
Excuse
day.
me. Um,
Oh, shoot, I'm not muted. I was just waving goodbye to someone since I'm going to a different room.
okay. No worries. So yeah, I was saying that in front of each sentence in a document, we had a special CLS token, which we used to make a binary decision of whether to include that sentence in a summary or not. However, I have also mentioned that we have this other way of summarizing or presenting summary to people, and that's by allowing rewriting and re-expressing the content freely. So in this summary, which is called abstractive summary, we have sentences that are not verbatim copied from the article. They are some content is selected and then it is rewritten more or less. So now, knowing what you know from this course, if I had asked you, let's say you have a quick assignment right now where I give you an article and I tell you, okay, you need to generate a summary like this, what kind of approach would you take? So this is a question for whoever wants to give it a try.
I'm sorry, could you repeat the question?
Yes, of course. So the task is given a document such as an NPR article. I'm not showing you the full article here, but the one you would get if you open this link. How could you, knowing the methodologies you know from this course so far, generate this abstractive summary like this one here?
This is pretty lame, but I think I would just feed it to a large language model and ask it for a summary.
Yeah, so basically asking a large LLM for a summary is a technique we call prompting, right? Like you would prompt a powerful LLM like ChatGPT, hey, summarize this article, and then it would produce a summary that looks like this. Very well. Yeah, that's definitely an most reasonable approach, probably. What else can we try if we, for example, want to change the weights of an language model? What kind of language model we would choose? What kind of considerations you would need to have in mind if we want to change the weights?
So I think we can use a fine tuning with multiple pairs of documents and their summarizations, but I'm not sure how to limit the number of output tokens or words to keep it as a summary.
Okay, yes, so that's right. We are using a fine-tuning approach, meaning we are taking a pre-trained language model and we are fine-tuning it, namely training it further in a supervised way, which means we have some pairs of documents with human-authored abstractive summaries. And then we are going to do, okay, instead of me telling what kind of objective we are going to use, can you specify what kind of training objective we would deploy in this case? You or someone else?
I guess it's again language model to predict to generate the next word. Yes.
Mm-hmm. Yeah, that's right. So just a next token prediction, and let's use the terminology token instead of word because we are now in the realm of subword tokenization. So our tokens are not necessarily words. Let me read the question chat. So what's the difference between prompting and question answering? Yes, so prompting, this is a slightly different question from what I'm getting at now. So let's finish me trying to get the full answer of what kind of method we are going to use to produce the abstractive summary. And then, Jeyu, I will come back to your question. So far we have said, okay, we are going to use a pre-trained language model. We are going to have some human label data, meaning a pairs of documents with human authored summaries. We are going to use next token prediction or language modeling objective, namely, negative log likelihood training, where we want to maximize the likelihood of producing a human authored summary for this. One thing that's missing here is something else about the model. So we said we are going to use next token prediction. So what kind of models, namely transformers, can we use?
For training the model, it must be a decoder because we want to match the attention. And for testing the same again.
Yeah, so what we want to use is a transformer type that has a decoder component, so it can be decoder only or encoder decoder. In both of these are fine options, and then I kept telling you that these days we have more of decoder only models like Llama, Qwen, Mistral. So most likely you will use one of those. So so we now fully specified what we need to use. Of course, there are small detail, not small, I mean big details such as for example, we have talked a lot about the efficiency. So if we are opting for prompting or fine-tuning approach, what is the hardware we have to store our model? We will choose the larger our model is, likely it is better at generating summaries. So we want to consider the largest language model we can place on our hardware. So we might be able, for example, fit a 70 billion model on a single GPU using quantization techniques, weight, and also using QV cache. So But then for fine tuning, since we need to store the gradients as well, we usually can fit a smaller size, and that usually means maybe 8 billion model or something like that is what we will use if we want to fine tune it. But remember, in the 15th lecture, we had this, I showed you kind of two slides. One was for classification, the other was for generation. And for generation, we had this protocol where I said, well, first you need to choose, check whether you have label data. In summarization, label data is a document paired with human authored summary, one or more human authored summaries. And if you do have that data, if you fine tune your model with that data, maybe that will give you the most specialized model for that task. That's a very, very strong baseline. But sometimes prompting, because we have less memory requirements, you can use the larger model. And by prompting that larger model, effectively, you might reach a similar performance as fine-tuning a smaller model. But then at this inference time, using a smaller model is going to be nicer. Either way, we are going to, if you are using Hugging Face, use auto model for causal LM if you are working with decoder-only models, which you likely will use. Okay, are there any questions about that? Okay, in the next slide, there is just another way of saying everything I say. I said sequence to sequence for abstractive summarization. Again, you have either fine-tuning option or prompting. This is also a nice visualization from paper by Goyal et al., where they also kind of basically show you another way of breaking down these options into fine-tuning, zero-shot prompting, and here at the time, instruction fine-tuning was just becoming a thing, so they make a, they emphasize you can use instruction fine-tune models, which today almost all LMs are instruction fine-tuned. Okay, so before I move on with, okay, now we generated this summary, how do we know, are they any good? I want to return to this question in the chat, which is, what is the difference between prompting and question answering? So prompting itself, I would recommend to think about it as a method for you to elicit certain behavior from a model. You want a model to do certain task, and you suspect that this model is good enough to do this task. It's just you need to crack the strategy of how to make it do the task. And prompting refers to crafting these inputs in a way that will enable the model to give you actual outputs you want to do. So that's prompting, and prompting indeed is very often posed as a question answering task where you ask the model, could you do this, right? It's a question. Could you write a summary for me given this document, and then it outputs the summary. But here I want to warn you about what I said in the question answering landscape lecture, where I said question answering is a task is when the question itself across different instances will be different, and the content of question is very important. Whereas in prompting, when you frame it as question answering, the question for every single instance is going to be the same. So for example, if you are framing summarization as question, hey, could you write a summary for me? Here is a document, and it writes the summary. This is what we would consider question answering format, because for every single document you want to summarize, you would use the exact same question. Hey, can you summarize this? Whereas for real question answering, for example, I give you an example from natural questions where the question was something about the brewing process. These questions in these data sets are going to be completely different from instance to instance, and that makes it question answering task where questions are full of content that are necessary to do the task. Does this difference, is this difference clear? Yes, all right. Yeah, so
Can I ask something on top of that?
yeah, of course, go ahead.
Would you say that question answering is under the umbrella of prompting?
No, again, I really recommend to think about prompting and question answering as, in a way I just described it, as two almost orthogonal concepts, where prompting is a method, like a way to get the model to do something, be it, question answering or summarization or translation, whatever task you want. And you can frame many of these tasks as question answering, but it won't make them inherently question answering task. So question answering as a task is a task where we want to get, we divided it into information seeking questions and the probing questions. But what is shared among all real question answering tasks is that questions themselves are crucial. The content, their meaning is crucial for answering that question. Whereas when you use question answering as a format for prompting being methodology to have LMs do something, whatever you care about, the question itself, it is usually something like, what is the sentiment of this sentence? What is the summary of this document? It's always the same, regardless of the document or a movie review or whatever. It's shared across all of these. And that's what makes these questions formats, not true questions in a spirit of there is a special meaning to them. So again,
Okay.
prompting is a methodology. Question answering, real question answering, is a very specific task. And then there is a question answering format, which is different from question answering task, which is related. This question answering as a format is related to prompting strategy.
Okay. No, thank you.
Got it. Any other questions? Okay, yeah, if you remember anything, just ask me. I like that you have questions, so just keep them coming. Okay, so now we have seen both how to do the extractive summarization and how to do abstractive summarization. So how do we know whether our generated or extracted summaries are any good? And the most standard measurement for summarization, you will see, oh, excuse me, I wanted to talk about blue, but in a second. What I want to say is that the most standard measurement for automatic measure of summarization quality is Rouge. And Rouge just measures, you have Rouge N, where N stands for the size of the engram. So you will have Rouge 1, Rouge 2, Rouge 3, whatever number for engram you want. And it takes your generated or extracted summaries. And there is a labeled data set where in this test set of this data set, you have human authored summary for that document. And you check how many, let's say, if we are talking about Rouge 2, how many bigrams occur both in your generated hypothesis summary and into your reference or human authored summary, divided by the total number of engrams in the reference summary. So in particular, Rouge 2 has been shown to correlate somewhat well with human judgments of quality of extractive summaries in the context of the multi-document summarization. When you have not just a single document you want to summarize on a given topic, but 3 or more documents. For example, instead of just taking NPR's article on the Boeing situation I have shown you, you could have taken from various news sources and then provide summary for all of them. And let's just see how Rouge 2 works again, just to make sure that this equation is clear. So your reference summary, again, we have this reference hypothesis notation that we have also seen in machine translation. So reference summary is a human authored summary. And let's say it says the quick brown fox jumps over the lazy dog. And then the generated summary, which I could also call hypothesis summary, could be a quick brown fox leaped over a lazy dog. So these are kind of similar, right? And first thing we will need to check is how many, if we are calculating Rouge 2, then our denominator will be total number of bigrams in the reference summary. So we are going to first check what are the bigrams in our reference summary, and we have the quick brown, brown fox, fox jumps over the lazy dog, and I ignore the period here. If we check what are the bigrams in the generated summary, we would get this list, and then we will calculate what are the overlapping bigrams, meaning bigrams that occur both in the reference and the generated summary. There is 3 of them, and then our Rouge 2 for this example will be 3, because there are 3 bigrams that occur both in the reference and generated summary over the number of bigrams in the reference summary, which will be 3 over 8. And this is going to be the quality of the generated summary in this very silly example. Is it clear how we calculate Rouge score? Oh, and Elham has a question. Does it make sense to measure the distance similarity of generated and reference summary as the evaluation metric? It does make sense. It, of course, the measure of similarity itself is going to be based on something, right? So, for example, if we think about distances in the vector space, that's indeed a way we do go about evaluating text generation, and I will come back to that in a second. I also want to remind you that, and this is what I had here as a first slide, that we had previously seen an example of how to automatically automatically evaluate text generation in the context of machine translation. And there we have evaluated BLUE, which is basically the geometric mean of the precisions for different engrams. So while BLUE is focusing on precisions of engrams, Rouge is focusing on the recall of engrams. That's one way to think about them. And you will see people both reporting BLUE and Rouge for text summarization. But Rouge has been traditionally more associated with summarization, and BLUE has traditionally been associated more with machine translation. But both of these will be reported jointly. We will just report for this task a bunch of various automatic measures because none of them are perfect. Which brings me to I didn't remember my slides very well. I just wanted to show you here the Rouge 2 scores for models around 2018. Remember 2018, it was when BERT was released, when pre-training fine-tuning had become basically the status quo approach to most tasks in NLP. And you can see here on the y-axis, we have Rouge 2. And what I wanted to just show you here is how big these improvements are from 2017 probably here to 2022. There has been almost 5% improvement in the Rouge score during that era of pre-training. So what I wanted to say is, before I see my slide with evaluation, is that I did say that Rouge 2 has been shown to somewhat correlate with human judgments of quality, but for abstractive summarization, in particular, when we have multiple documents we want to summarize. However, when we enter abstractive summarization, now rewriting and re-expressing is allowed. And there are many reasonable summaries. You can think about, there is a human authored summary, which you can think about as a gold standard. But then you can paraphrase this human authored summary in many ways. And all of those, if they are keeping all the information and are not, introducing any notable length to the summary, would be an acceptable summary, right? Like you just paraphrase the information. There is it's likely going to be equally good. So Once we are allowing re-expressing and rewriting, evaluation becomes way more challenging. So people have shown repeatedly that measuring summary quality with where summaries are of the abstractive type with Rouge 2 is very unreliable. You will get scores that are high for summaries that are not judged to be good by humans, or get very low scores for summaries that are judged to be good by people. And remember, this was also the case with machine translation and Blue. If you go back to lecture 9, I have shown you over a dozen problems with Blue for evaluation of machine translation. So, as always, once you start generating text, it is the best to use human evaluation, which means that you recruit some people to read your text, generated text, and tell you, is this good according to some instruction of what good in this realm is. However, the issue with human evaluation is that it's slow and costly. And I think by now in this course, doing your homeworks, you have realized how useful over experimentation is, where you try a bunch of different hyperparameters, and then you have seen, okay, these are the best for the task. That's great when you have a nice evaluation measurement like you have for the task you have tackled in your homework, where you have accuracy, right? But if we would need to require human evaluation, which can cost dozens, if not hundreds of dollars for every experiment, then this kind of prevents you from testing which hyperparameters are good, and that can lead to suboptimal performance down the line. So the fact that human evaluation is costly and that it's also slow is preventing us to do this machine learning development the way we like to do. So there continues to be the quest for these automatic measurements in NLP, where we can automatically say whether text generation is good or not. And I will now show you other approaches for automatic text evaluation. I will also talk about how do you go about human evaluation, and we will eventually wrap after seeing a bunch of these other automatic measures. Are there any questions so far? Okay, so yeah, we have seen Blue, we have seen Rouge. One thing that's important to recognize with both Blue and Rouge is, or I should say Blue and Rouge, is that they are just checking the overlap between bigrams, right? So they're looking at the exact words that have been used in the summaries or, machine translation generation, and check whether they are the same or not. And sometimes you will hear people refer to these measurements as lexical overlap measurements, because lexical usually refers to words, and overlap because we are checking whether words are overlapping or not. Now, highlighting that a distinctive property of Blue and Rouge, can you tell me how that can be an issue, especially if you want to evaluate, let's say, abstractive summaries? Can you think of an example where just checking the overlap between words is going to fail if you want to evaluate two summaries? Like one you deem to be gold standard, ground truth, coming from a person, and another one which is generated by some model. If we are solely restricting us on the overlap between words or bigrams.
Yeah, I think if we have different words that have the same meaning, in that case, this won't work.
Exactly. As soon as we have any kind of paraphrases or synonyms, this is going to fail, right? Like we can have two summaries that are direct paraphrases of each other, we have used different expressions. And because these lexical overlap measurements like rouge and blue are looking solely on these surface level features, then you will get maybe even like zero overlap, where these can be, it can be a perfect summary because it's a direct paraphrase of your gold standards. There is a question, if you didn't change anything, wouldn't the rouge score be perfect because the overlap would be 100%? Yes, that's true, but I don't think that's an issue, because if your model had created a summary, that's exact summary that a person would write, well, that's very good. But the case is that almost never you will get an exact summary if you're working with the abstractive summarization. Maybe with extractive, because you are copying things verbatim, but with the abstractive summary, if you had obtained a summary that is exactly the same as a summary in your held out test set, which must be unseen during training, I would be concerned, because then I would think somehow my test set ended up in my training set. So producing the exact summary would be highly suspicious. But then it's not that Rouge is doing something weird. It's rather I would go back to my data split stuff and see whether I have any bug there. Is that clear what I'm saying right now? Yeah, okay, great, thanks. Okay, so all right. So far we have said we kind of hate that we have these exact overlaps between words, and can we do something better, right? And I feel like we had this problem already before. So maybe without knowing the exact next measurement we are going to produce, do you have like a high level idea of what we should start doing now? Like, instead of doing overlap of words, if we want to have a little bit more flexibility, what did we do before that might be useful here?
Embeddings.
Embeddings, perfect. Yeah, I love that. That was so fast. Yeah, so far we always, when we had the problem of, this thing is so rigid, like we are just checking these exact overlaps, we have said, well, let's turn things into vectors, where these vectors are going to be closed in this vector space if they are similar, and otherwise they will be far away from each other, and let's check for the distances in this vector space. So that's the idea behind BERT score. In BERT score, you will represent your reference summary, meaning human author summary coming from the test set of your data set. And you will also represent your generated summary using BERT. What that means is you are going to pass these summaries independently through BERT, and then use some final representation to represent that summary. So for example, with BERT, we have that special CLS token that represents entire input sequence. So if you had passed your reference summary through BERT, you can use the CLS token at the final layer of BERT to represent the reference summary. And then independently, you will put your generated summary through BERT, and you will again use the CLS token to represent your generated summary. Now we have two vectors, and once we have two vectors, we can use the standard measures of similarity, such as cosine similarity, right? And in this case, how BERT score is presented, introduced, you are not doing any additional fine-tuning of BERT. Rather, you use pre-trained BERT to get the vector representation of your two summaries, and then you check the similarity between them. So no additional fine-tuning in this done. And it's pretty simple. Any questions about BERT score? No? Yeah, I think that's pretty straightforward. If you had came to the point where when I say just represent a sequence with BERT, you're like, yep, I put it in BERT, get the final representation of the CLS token to represent the entire input sequence. I think then this is the most standard thing that you can try. There is another version of this which is slightly more complicated, and you will see it sometimes reported, but a little bit less, maybe because BERT score has just gained a lot of attention in the community. But another thing that people have tried is a mover score, where again, you represent your reference summary and your generated summary using, let's say, BERT. So you get two vectors, one for generated, one for reference summary. And then you're trying to find the shortest path to convert your vector that represents your generated summary into a vector that is representing your reference summary by doing some constraint optimization problem. And now this is more complicated as an idea. We are not going to go into details of that, but you will just use the available implementation of that. You wouldn't do it yourself. Okay, so now the one other measurement that I want to mention that is using these vector representations and is checking their similarity is BLERT. And BLERT is basically it's kind of building upon BERT score. It's also produced in, I believe, by folks at Google that kind of just tries to fix one thing with BERT score, and that's that it's not specialized for the task of measuring similarity between two pieces of text. And it's going to take a BERT and fine tune it for the purpose. Yeah, it's a funny name. I believe that there is some play on word with French here, and I believe one of the authors is French. Yeah, this is how BLERT has been developed. So BLERT, again, wants to do what BERT score does, but it wants to also tailor BERT additionally for this purpose. So what they do is they fine-tune BERT in two ways. And then after they fine-tune BERT, they're going to use BLERT in the same way that BERT score does it. They're just going to use their fine-tuned version of BERT, take two vector representation and measure the cosine similarity. So the only thing here changes that instead of using pre-trained BERT, they are going to use specialized BERT. And what they basically want to achieve with their fine-tuning of BERT is that when you get two pieces of text, there can be really subtle nuances of why these two pieces of text are different, but it can have this simple, small syntactic or semantic difference can make a huge difference on the quality of this summary. So basically, they want to fine-tune BERT in a way that they give two texts that are similar and that might have different, judgments of quality of these two pieces of text serving as, let's say, summary. So in the first stage, they want to have a larger scale fine-tuning. So if they want to have a larger scale fine-tuning, that means that it would be better for them to use measurements but to use a procedure here that doesn't require labeling data, where some person takes two pieces of text and labels whether these two are similar or not, and whether one is better than the other. So to kind of circumvent human annotation here, what they do is they sample sentences from Wikipedia and they apply some random perturbations to one of them. For example, they use mask language modeling objective. If you remember, that means masking some words in your text and then having BERT fill in the gaps. They use back translation. That means you use some translation system, and let's say you translate a sentence from English to, let's say, Chinese, from Chinese back to English. So that's back translation when you are going back into the English, which will cause some small variations. And they are also randomly dropping out some words. So they're using these three different strategies to produce from a single sentence various perturbations of that sentence. And what's important here is that they use perturbations that won't radically change the original sentence, just subtly. And this will allow the model to learn subtle differences between two pieces of text, such that later when we are using it for the purposes of text generation evaluation, the model has a chance to understand, well, these two pieces of text are seemingly different, but they are actually differing in this subtle but important piece of information, and therefore one is better than the other as a generation. So, okay, so in this first stage, they created the data like that. And then, so here are coming back to the point I said earlier, that ideally you would have some human telling you which pair of these sentences is better. And then you would train BERT to score the better sentence more highly. However, here they want to do more large-scale fine-tuning to be able to cover diversity of subtle nuances between two pieces of text. So instead, they are using the previous automatic measurements like rouge, blue, back translation quality, and others. And basically, they are now fine-tuning BERT in a way that, given these two pieces of text that they have created in this step, to score them in a way that's going to be aligned with the various of these measurements, such that the sentence that's better in this two pair is scored more highly, despite just subtle differences between the two sentences. That's the first stage. In the second stage, they are actually going to use data where they do have pairs of texts and judgments of which one is better. So here they are additionally, after prepping BERT that, okay, these are the subtle differences between two pieces of text. Here they're additionally polishing it for the task where, given two pieces of text, score the one which is judged by humans to be better, score that one more highly. After all of that is done, you are done with your preparing BERT like this, and then you are going to use that BERT that has been produced in the same way you use BERT score. You get the contextual representation of your reference summary, of your generated summary, and then you check the cosine similarity. One thing I want to emphasize here is if you have your own data where you have pairs of text and human judgments of which text is better, you can, as these authors have, fine-tune your own BERT to produce your own version of BLERT specialized for the task. And this can be especially helpful if you work in domains like medical or legal, where the text is different from what BERT and this version of BERT BLERT have seen during their training. And you can specialize it better for, to achieve a better automatic measurement for your task. However, what you would do now is not do any of these fine-tuning steps. That's done. You can just use the BLERT, which is basically the specialized BERT that you then use, like we have said, use two contextual representations and check the cosine similarity between them. So right now, if you just need to evaluate a bunch of summaries, you would use BLERT, which is based on underlying specialized BERT, to get the cosine similarity. You wouldn't do this fine-tuning yourself. However, if you deem that your task and domain is very different from this, what BLERT has done, and you have some available human preferences, then you can fine-tune your own BLERT. Okay, so I said a lot. Let's see whether there are any questions about this. Okay, I just want to check that we are on the same page. So
Let's see. I definitely should have a question. You're right. You did go through that. I guess with BLERT, maybe go over the differences between BERT and blurt again about how it like gathers more information?
Yeah, I mean, that would require to repeat everything I just said. So can you make your question a little bit more specific? So with BERT, we have BERT the way we know it. That's a pre-trained language model. And then with BLERT, we have specialized BERT using all of these steps. And now we have just another version of BERT that we can use to get two representations for reference and generated summary and measure their cosine similarity. So is any of these steps unclear, or?
Now that you put it in, that does make is about what it is. Maybe about how to apply it. When we start using it in our code, is it going to be as simple as just importing it, or we're going to have to do more steps?
Yeah, you're basically, if you just want to use it, then you don't need to do any of the fine-tuning step. You're just going to use the available code base. So for example, here you have commands that show you how you can use BLERT using this code base, which is basically running the command Python, and these are the script for that the Google folks have written, and then you just need to give your they call their generated generations candidates. So candidate file will just be a file where you have generations, and the reference will be a file where you have the human authored in a summarization, it would be human-authored summaries. In translation, it would be human-authored translations, and so on. This just specify which checkpoint, like which of they have introduced multiple BLERT models and which one exactly you are going to use. You run this script and it gives you the output.
Yeah, that's really good. Okay, thanks.
Thank you. Douglas?
Okay, so on the slide it says that you're fine-tuning BERT to mimic the scores of these metrics. Does that mean that BERT is giving a different output than it was before? Like have the models changed so that it's not predicting the next token, but it's now maybe like predicting a single score between 0 and 1? I think I might be missing something there.
Okay, so I just want to make sure that we are working with models for both generating summary and for evaluation. So now which model is which can get a little bit confusing. So first, we are not talking on this slide or in this current moment about models that are generating summary. So that the model that's generating summary, depending on the type of summarization you want, can be BERT, or it's Quen or Mistral or whatever. So those are models that generate summaries, and you have used them, and now you have generated some summaries. And now we are talking about how do we know whether these summaries are good or not. And now we entered a very weird space where we are using also models to give us this piece of information, whether these just summaries generated by another model are good or bad. In this specific example, the model we are using to tell us whether the summary is good or not is a pre-trained version of BERT or a more sophisticated version of BERT. And now I guess I come to the exact question you ask is what exactly is the output of that model, right? And again, we are using these models, both BERT and BLERT, to we are basically not using their output layer that we have used during their various training stages. Rather, we are using that layer before the output layer to get the contextual representations and then measure the cosine similarity between two of them. So similarly, how we use BERT score. Yeah, I mean, so it is true that BLERT, because we have been fine-tuning it in this way, does have an output layer which is specialized for some sort of similarity between two pieces of text. But it is a slightly more complicated than that. I don't want to go into these full details because I think what is important for each one of you to know is exactly what I said before your question. You just use this, command to run the Python script. But if you are interested to know in more details, it will just take me a lot of time to cover all these details, which I don't think are super important. Then here, let me just show you. So in this section 401, they talk about how they create this data. And then they say, well, for our supervision, we are going to use these various pre-training signals. And I just want to also emphasize that what they call pre-training here, I used the term fine-tuning because for me, like fine-tuning is that step after long pre-training. So just a heads up that I changed the terminology a little bit more. So they say here what I told you on slide, that they use these various measurements. So if you want to fine-tune BERT to mimic, let's say, rouge, and rouge itself is a score, it's a scalar, it's a single number, then you need regression. However, here they are then talking about other signals, which I didn't talk on the slide, such as back translation likelihood, which requires other type of output layer. And then they talk about textual entailment, which is a whole other type of output. It's a 3-class classification. So what I want to say here, I'm certainly just overwhelming you right now. I want to say that although I have just said, well, they need to mimic scores like blue and rouge, this is slightly more complicated, and BLERT involves various output layers to do this. But eventually what happens from all that training is that you just get representations from this specialized BERT model, BLERT, that are great for measuring the distances with cosine similarity between two vector representations, if that makes sense. Okay, cool. Okay, so far we have been talking about these, we have went from lexical overlap measurements, and please remember this, when someone tells you, these are lexical overlap measurements, think blue, rouge. Now we enter the different kind of category of automatic evaluation of text generation, which are these measures that are based on vector similarity. We talked about BERT score, mover score, and now BLERT, which is the most specialized of them all. Now, slightly different evaluation, automatic evaluation, is so-called QA eval, which is a really neat idea where, given your reference summary, you are using some language model that's capable of generating question-answer pairs from those summaries. So think about, you give a summary to human-authored summary to ChatGPT, and you prompt it with, hey, can you generate 10 questions and their answers to these questions from this reference summary. And then you have basically a small data set of questions and answers based on that reference summary, with the idea being that if you can then give those questions, to some question answering model, and also give a generated summary. If that generated summary contains all the information contained in the reference summary, then the question answering model will be really good at answering those questions that were created based on the reference summary. So your measurement of the quality of your generated summary can be the proportion of the questions that have been generated in the context of reference summary that have been answered successfully by some question answering model based on the generated summary. And of course, here there are some finicky details on about what the quality of these generated summary, generated question answer pairs are, and what is the quality of a question answering model. In this paper, they have shown this to work for certain domains, for certain tasks, but maybe you should be just slightly cautious of whether this will work for any single possible summarization task. By summarization task, I mean summarization applies to a domain, specific domain, like if you have something like medical, some very, very specialized medical language, then in general, these automatic models for generation of questions for answering aren't going to be so good as those that are created for news. So that's another one. This one isn't as widely used, but I think the idea is a very neat. You will see it in the, if you go to the most recent publications in NLP conferences and summarizations, you might see this measurement too. So it's not like it's completely ignored, but not as commonly seen as a Rouge, Blue, and Bird score or BLERT. Okay, so there is QEval, and now I'm gonna tell you about our holy grail, right? Our human evaluation. And at the same time, I'm going to talk about this idea of LLM as a judge, which is basically using a very strong LLM like ChatGPT to be a proxy for human evaluation. So basically, you can either recruit a person and give them some instructions, or you can put those instructions into ChatGPT, and hopefully you get the same ratings of quality of summaries. This is what we mean by LLM as a judge. Using LLM in exact same way you would, instruct a real person to do the evaluation. Here, it's important that there are not a single human evaluation type. You can have at least two. So, for example, you can have so-called pairwise comparison, where your judge, either human or an LLM, is presented with the input. In text summarization, input is one or more documents, and you present it with two generations. And you ask a person or an LLM to determine which generation is better, or to declare a tie, meaning to say they are both equally good or they are both bad. And then here you would report a fraction of times that generations of your system are winning over some baseline, and that should be with a rate which is higher than, let's say, 50%. Another type is that you have single answer grading, meaning you present the input and the generation, just a single generation of your system, and you ask a judge judge can be either human or LLM, to directly assign a score to a single generation. Sometimes here people are also using so-called reference guiding, where you also provide a reference. For example, you can provide a human authored summary, and then relative to that human author summary, you can ask a person or an LLM to score the generated ones. So here, I also want to immediately mention this choice, which is whether you want to provide a definition of quality, summary quality, or not. Like, do you want to tell to people, this is what a good summary is, or you want to leave it to people's interpretation or LLM's interpretation of a good summary is? And you will see in the literature that there are different choices people are making. For example, in this work by Goyal et al., they are looking at the summarization of news articles, and they say they don't actually want to give people any notion of what they deem quality of a summary would be, because they don't want to bias people to, just take the certain definition the authors of this paper have in mind. They say with news summarization, there are many different things people consider when they judge the quality, and for them, for this particular task, for particular domain, they don't want to constrain people's evaluation with whatever notion they had in mind. However, in some other domains, think about, let's say, medical domain, you might want to provide more detailed guidance. So This choice, I think it really depends on what kind of summarization you are doing and with which purpose, right? I mentioned here medical because I think in medical domain there is some certain notion of quality is, I would say, very specific. You don't want your patients to return with newly developed symptoms or symptoms that are still happening. So you want the summary that's best for that, and then you can guide your annotators to have that in mind when they are evaluating. Okay, any questions about that? Yes, Elham, I think you have a question.
Yes, if there is no reference to avoid the bias, so how do they evaluate the models then?
Here, when you have human evaluation, and you can just show the generated summary, and then they can tell you whether it's good or not, right? What I'm saying here is basically how do you instruct people to tell you whether summary is good or not? Are you telling them, this is my definition of what does it mean for a summary to be good? And you should, regardless of what you might be feeling about this summary, you will, even though it might be bad according to my definition, but not according to you, you will still say it's bad. I think another thing might be confusing here. When I say reference, I mean human authored one. So reference, that technical term of human author ground truth summary. If you're doing this evaluation, you are always going to show the generated summary because that's what you're trying to evaluate, right? But they don't need to see anything that any person thinks about the summary if you are asking another person what they think, right?
Makes sense, right?
Okay, so okay. Sorry, do you have another question, or that's just the previous hand? Okay, cool. All right, so let me show you just two prompts that you can use for LLMs as judges. So here, and I will read it out loud. So you will give a system prompt which says something along the lines, please act as an impartial judge and evaluate the quality of the responses provided by two AI assistants to the user question displayed below. You should choose the assistant that follows the user's instructions and answers the user's question better. Also, this prompt here is not for summarization. This prompt is for long form question answering, when you're answering question with a long answer, not just a short span. But you can imagine what kind of things you would change if you were using this for summarization. So here we can say you should choose the assistant that follows the user's instructions and summarizes a given text better, for example, for summarization. Then it says your evaluation should consider factors such as the helpfulness, relevance, accuracy, depth, creativity, and level of detail of their responses. And this goes back to what I just said. Do you want to nudge people about what do you care about for quality or not? Or do you want to leave it up to the interpretation? Then they say, begin your evaluation by comparing the two responses and provide a short explanation. This explanation can be helpful later when you check why the model had decided certain answer over the other. Avoid any position biases. Ensure that the order in which the responses were presented does not influence your decision. Now, position bias is a bias that LLMs exhibit, where if you give two generations, the order in which you present them, unfortunately, matters. So if you give, I believe that whatever is, I can't remember that whether they prefer the first or the second. So it's not about the content of those generations. It's just about whether you have placed them first or the second in your prompt. Now, just saying to model, avoid position bias, it sounds a bit strange, right? Like, how can we assure that the models really are not doing that, right? And I will give you reference in a slide or two that gives a little bit more controlled way of ensuring that position bias is not a reason why one generation is favored over the other with these LLM judges. It continues, we do not allow the length of the responses to influence your evaluation. This is another observation that people have shown that longer the input is, models at the time had said those are better, let's say, summaries than shorter ones, although they were not, just because they were longer. One thing you can check is when you are getting the scores out of these LLMs, you can measure the correlation with the length and see whether, if there is very strong correlation with length, then that should be suspicious. You can maybe be concerned whether the quality is judged based solely on length, although that should be irrelevant. And not irrelevant, but not the only thing we look at. They say do not favor certain names of the assistants. That's another thing I would never give the names of the assistants. Like, that's an easy thing to avoid, models to pick on. Be as objective as possible. After providing your explanation, output your final verdict by strictly following this format. A if assistant A is better, B if assistant B is better, and C for a tie. This is also important, but because later, if your model is too free in how it can express the generation it favors, then it's going to be hard for you to compute the final measurements of how many times A is better than B and B is better than A. So you want to have the same format outputted always, such that you can easily extract the information. Okay, any questions about this prompt? And then it goes with giving the information that's needed. Another prompt is, and I won't read it out loud, but this one is for providing the rating, right? So it says, please rate the response on a scale of 1 to 10 by strictly following this format. So instead of giving 2 generations, we are giving just a single generation, and we are getting the absolute rating. I want to go back to question Elham had as well. So here, maybe you are wondering, what are the 2 generations we are giving? You can, in NLP, very often we are trying to beat some baseline, right? There is the best current system, be it in industry, be it in academia, right? Like in industry, someone probably has some prototypes, something built, and you want to see whether your new model is better than that old version. So the old version is called baseline. So very often you will pair your new systems generations with the best previous systems generations. Sometimes people will actually here also use human authored outputs. And that's when you suspect your task might be really good already, and you want to say, well, my system is on par with human authored abilities in this specific data set. So sometimes you will also see with human outputs presented over here. Another thing that's not mentioned here explicitly is that you want to shuffle the order in which you give the generations. So although we are using assistant A and B here, you don't need to, sometimes you can give the generations of your model as assistant A's generations here, and sometimes as assistant B's generation. So this is just to circumvent the issue where the model might be picking, A here for no reason, just because it prefers it. Okay, so I want to do digression. Do we have time for digression? I guess I will come to my digression at a better moment. Hopefully I remember. So as I said, these are prompts we are giving to LLMs like ChatGPT, for example. However, when we do human evaluation, then we would actually give them very similar instructions. Maybe there will be just like, you will at the beginning have something, thank you for, doing this task for, like something like more like polite human interaction first. But the rest of the rest of the stuff will be similar. You likely want to say to people, please act as an impartial judge. That's a bit strange. You would say your task is to judge and evaluate the quality, right? Like you will assume that the person is being in that mindset, which we do need to tell to LLMs because we are trying to have them act as certain personas. So there are slight differences in how you will give your instruction, but the more or less you will give something like this to your human annotators as well. Where do you find these people? Well, need to have some money, and that usually comes from your advisor, your employer. And then once you have the budget, you are going to go to platforms like Prolific and Amazon Mechanical Turk, where you are going to recruit people. And you do want to have a sample of at least 100 instances. In the context of summarization, instances are document that you want to summarize or more documents you want to summarize together with the generated summary, or a pair of summaries you want to compare. That's what I mean by instance. 100 is absolute minimum. I would say 250 is something you would see in an NLP publication. More you have is better, because otherwise the differences you are getting between your generated summaries and the best previous generations might not have enough statistical power. Like you might get differences that do not mean that if you had a larger sample that you would observe the same differences between those two systems. So the larger number of instances you have, the better, but more you have, more money you need to have. So there is a balance between the two. You will also see that people usually recruit annotators in a way that they have, multiple annotators evaluating each one of these 100 instances. And this is to check things like subjectivity and disagreements. If you have one person saying that they prefer your generated summary over the other one, but then when you have three people, two people disagree with you, then that becomes an issue. It's not that vote seems to be outlier rather than what is true. So people recruit three people, they will report some disagreement measurements, and they will also take the majority vote for that instance to be the final vote. And participants are usually paid somewhere between $11 to $15 per hour for these kinds of work, unless you need to work in a domain which requires you to recruit, highly skilled professionals like doctors, which you will certainly need to pay way more. Okay, so I have already mentioned some issues with LLMs as judges. We talked about position bias when LLM favors certain positions over the others. So in this paper by Zheng et al., they say when GPT 3.5 answer is position first, GPT-4 consider its answer more detailed and superior. However, upon switching the position of the two responses, GPT-4's judgment flips, favoring Vincuna's answer. Now this judgment is useless, right? If the LLM judged one models to be better just based on whether its generation was presented first, that's a useless vote. Then people have shown that LLMs judge generations which are longer, more verbose, even though they are not as clear, high quality, or accurate as their shorter alternatives, which is exactly opposite to how humans prefer generations. Of course, there is LLMs judging, their own generations more favorably. So if you ask GPT-4 to you give it a pair of generations, one created also by GPT-4 and another one by some other model, it will prefer its own generations. And then when models have some limited capabilities, for example, LLMs right now are not amazing at math and more complex reasoning, then using them to judge outputs for math and reasoning obviously won't be good either. So, all right. So what to do? Like you have all these potential issues, but you really wish to have some automatic evaluation. So what people do is first this is a new area of research. So let's say for this paper by Wang et al. In ACL this year, they have introduced a calibration method which prevents LLMs to pick generations solely based on whether they are presented first or second. So you will see these additional new tricks to include such that some of these biases are accounted for in the evaluation. However, it's still new, so you can't just be using LLM as a judge and say, this is a perfect method. So what is absolutely needed is that if you're working on a new task in a new data set and no one else has reported the correlation between human judgments of generation quality in that data set with automatic measurements, then you absolutely must do it. Otherwise, if someone else had reported a correlation, you can say, all right, someone else for this specific data set had measured the correlation of human judgments of quality with LLM as a judgments of quality and have shown higher to moderate correlation. This will be a sufficient signal for you to use LLM as a judge for intermediate development. However, always at the end, did I write this here? At the end of you will use these automatic measurements for your intermediate evaluation, but your final evaluation will always be human evaluation. That's simply required to be sure that what you have done have certain level of quality under our reliable measurements, although human evaluation can also have some issues, but not as severe issues as any of these automatic measurements. So I also want to mention, let me see, okay, there are also a few things in terms of how these evaluations can become a little bit more involved than just asking people the judgments of overall quality, which I'll come maybe in a second. Elham, you have a question?
Yes. So what is the final evaluation? Like, what is the difference when do we say it is a final evaluation and when can we use the LLM as a judge?
Oh yeah, I wasn't clear enough. So as we know, when we develop these models, there is a lot of intermediate development, choosing hyperparameters, choosing this, that, data portions, whatnot, right? So for all of these, if you have a sufficient correlation between human judgments and some previous generations of someone else for this specific data set and task, then you can say, well, someone else has previously in this data set who work on this data set have shown that for their generations, there is sufficient correlation between human judgments of those generations and LLM as a judge. So it seems like this LLM as a judge is an okay measure to be using. So you use it, throughout the modeling process, but eventually when you are done, you have everything is done, you will also do human evaluation as the final evaluation of your method. And this is just the final thing you do in terms of evaluation. So what I want to say, in other words, is don't skip human evaluation, even though there is some signal that it's well correlated with LLM as a judge, especially for NLP research. There is an expectation that you will report it because there is just so much suspicion around these automatic measurements from Blue, Rouge, Bird Score, Blur to LLM as judges. So final human evaluation is necessary or expected, I should say.
Thank you.
Yeah. And maybe in this last minute, I have a few more things I want to say about generation, but I just want to show you then how the final reports of measurement looks like. So here, for example, there are three models, Brio, T0, and GPT-3, and they are used for generation in this summarization in this paper. And then CNN and BBC are two different data sets, so summaries that come from these two different data sets. And then here they do that preference-based evaluation where annotators have chosen, good and bad summary from a given set of summaries. And here you can see how many times has GPT-3 has been judged to be the best and how many times it has been judged to be worse, which is obviously higher number than for any of these. So it seems to be the best one. So this is how you kind of report the aggregate measurements. Here because they had 3 annotators per instance, here they have also provided a more fine-grained visualization of these results where they showed, well, what is the proportion of instances for which, let's say, GPT-3's generations have been set to be the best by all 3 annotators. And you can see that the number of those is way larger than for the other models. And whereas very few instances were judged by all 3 annotators to be the worst for GPT-3 generations. You will also see these other automatic measurements in papers. So here you see we have Rouge, I didn't talk about Meteor, which is another overlap-based measurements to see how people emphasize overlap for these measurements. So blue, then we have BERT score, mover score for similarity-based, and QA eval. So most of the measurements I have shown you today. And what you can see here is that under these automatic measurements, it seems that GPT-3 is the worst. So it seems to be the worst according to these previous measurements, but according to human evaluation, which is the holy grail in terms of evaluation, it is the best one. So this shows you how these automated measurements can be failing on text generation evaluation. And this is why we really want to have automatic measurements, because development becomes terrible if you don't have them. But solely relying on them can lead you to nowhere if they are not correlated with human judgments of quality. Okay, so I'm 2 minutes over time. Sorry about that. I will stick around if there are any questions on, as I said, I'm gonna leave today to attend EMNLP. So tomorrow's office hours with me are not happening. And then on Wednesday, Matre, who is a PhD student in the NLP lab, will talk about multilingual language models. So I will stick around here for a few more minutes if there are any questions. Otherwise, yeah, have a great rest of your week and see you next week.